Good morning. I'm back live for a short stream today. I think I'm going to do two shorter streams, depending on how much stuff I get done. I want to make this ideally the last day of writing that I have to do. Let me open up the chat and open up the article, and then I will tell you what we're doing today. I am also traveling tomorrow, so there will be no stream tomorrow. And okay. Here's the plan. We finished the draft of this guide. Between this one and this one, we have over 20 pages of content. I'm going to attempt to, in the next hour, write the last section, proofread all of these, make any fixes. Hopefully I'm happy with this as it is, and then that will be set. I'll have to get images for these, but otherwise it'll be set. And then later today, I think I'm going to just do the paper edits. The camera ready. Welcome, chicken. So, did I actually have 10 sections here? No, I didn't. I kind of just put this random thing. So I realized the thing that I realized that I didn't do is I didn't give you like some of my super valuable, just like from experience advice on how to do things all in one place. So that's the section I want to add. Because right now we have this intro, we've got building something simple, we've got some fundamentals, we've got build some more stuff, we've got some more fundamentals, we've got build more stuff, we've got some background material, and then here we are. Let me go check our quick start guide real quick. Because I have a lot of it in here. Yeah. So a lot of it is kind of this like the bottom section here. So like let's just get the bullets here, right? Um So we have like simplicity, the iteration speed, and your data. I don't want to just duplicate this section, right? Mm. Oh yeah. But people are gonna want to know like the way more specific stuff. I'm trying to think how much of that I even have. Like honestly, a lot of the stuff that makes me good at RL is pretty dang general. I mean, it's stuff that it's stuff that's useful in a lot of places, but matters a lot more in reinforcement learning. Like the whole focus on simplicity and iteration speed and stuff. It's good to do this in a lot of general engineering. It's just that like you get punished way, way more heavily if you don't do this in RL. Let me go look at like somebody actually sent me some messages, I believe, in Discord's got a update. Check this message from Spencer real quick. Where did he post this? Adrian. Thing. Where was there was a guy that like posted like a whole bunch of stuff. I can't keep up with this chat at this point here. Generally when something's really broken, a bunch of people slap me at it. Where was it was Magidur, right? Oh yeah, here it is. How to approach. Yeah, so a lot of this stuff is docs. Okay, we can talk about things that don't agent. We do like multi-agent. Is that even like a thing? Valuation. Yeah, maybe what to log. What are good logs? Log. How to approach a problem in general. One. Observation and action spaces, I suppose, right? Let's do like a, instead of just doing bullets, let's do a paragraph on how to approach a problem. That'll include most of these. Let's just start writing this paragraph and let's see what this does. Where we get with this. This is the designing the observations is a little bit more technical. Yeah, so there are bits of this that are more technical and bits of this that are more general. Let's do like how to with data. It's important. if anybody has questions, general RL questions, how to approach problems or things, like, they will get into this guide. If you ask a good question, I will, like, put it into here. This is the reason I'm streaming writing, which would normally be very boring otherwise. Trying to think if there's anything else I want to add here. I pretty much covered all of this already. Do I write a quick section on research? I think I can put it in here. I can actually, it's like 2 sentences. I have no experience in this space, but I find this all very interesting. Thanks for taking the time to contribute this. Yeah, I gotcha. It's I don't do a ton of educational content. Most of my stuff is like how do we push the cutting edge of research, but a lot of it has been at this point like contributors jumping aboard and helping us with stuff. So I figured I'd give a little bit back to those people, and then also I hope that this will get more people interested in the research side and helping with all the stuff that we're working on as well. This is going to be like 20 to 30 pages of material released with this guide. I think what we'll do is we'll do it for 10K, 10K followers, because we're almost there. Okay, I'm gonna just read. I think I've got like half an hour left before my meeting almost. So I'm just gonna read through this whole thing. I'm gonna actually read through the other one as well. I'm gonna see. I think I have just enough time to do that, and we'll see if I think it's done. So by popular demand, right? By popular demand, I wrote a second article. Heck. If you have time to answer, oh, want to chat this afternoon? Yeah, Spencer, I can do that. If you have time to answer, what's the background motivation of this guide's target audience? I mean, we just have a lot of new people that have been asking me, and like people come into Puffer from all sorts of different, where is it? All sorts of different backgrounds. Here, like people asked me for this one because some people are new to a lot of stuff. It's pretty much how do we take people coming in from all sorts of different backgrounds. Some people know math from a different area but have terrible programming. Some people have strong like a systems background but no math. Some people have both but have never done research, right? Um, so it's just trying to take all these people from different backgrounds and just get them up to speed on this is how you get into reinforcement learning. This is how you get from wherever you are to the cutting edge of the field. And I mean, you can apply RL using that. You can help us with research. There's not really any difference. RL is not an area where, like, if you know a little bit, you can apply it. If you know more, you can do research. You kind of just have to be good to make anything work. So there's not really two separate paths there. Okay, let me start reading through this. Can I just read this out loud? Why not? This article is a prequel to my opinionated reinforcement learning guide. It exists because people have asked me for it repeatedly. Start here if you A, do not know how to program, B, don't know ML, or C, started reading the main article and were confused. See A and B. How to learn to program. Having a PhD in AI does not mean you know how to code. Having access to an LLM also does not mean you know how to code. Thinking that either of these do is probably a negative signal in general. Being a programmer is harder than being good. Being a good programmer is harder than being good at AI. Every good programmer who has started doing RL with us has done very well. Most of programming is very simple. Simple does not mean easy. The thing that makes programming hard is that it is often terribly taught in a way that trains you to overcomplicate everything. Unlearning this takes either years of failure and pain or a particularly open mind. Your entire outlook on how to program could be stupid and wrong. If you're brand new to programming, you have an advantage here. If you're not new but are reading this anyways, I invite you to make this decision now. So yeah, all these articles are written to be very, like, they're written as provocatively as possible while being, like, strictly true, or strictly true in accordance to my experience. Because part of that is because I like doing that, but the other part of this is, like, I really think that this needs to be a sort of a mold breaker kind of a thing. The way we do our stuff in RL is not the way that it's done anywhere else. And flipping that perspective is very hard, and it needs to be told bluntly. How to learn. Thank you very much. My eyes completely went over that. Thanks, Nick. If any of you see typos or things, please let me know. Programming is the act of writing down instructions that operate on data. The list of instructions is relatively short. Create variables by assigning data to addresses in memory, evaluate conditions on variables, loop over conditions to run the same set of instructions many times, group instructions together into functions. You can learn the tools of the trade within a few hours, but applying them effectively is the pursuit of a lifetime. Skill in programming is not logarithmic. A bad programmer creates problems. A good programmer solves problems. A great programmer can change the world with nothing more than a laptop. Enough philosophy, here are my top 10 suggestions. Learn by doing. Start with something that will take you a few hours, build up to something that will take you a few days. Simple games are great because you get a quick visual feedback. Because you get quick visual feedback for most problems. I'd suggest using Raylib for rendering. Lightweight, available in nearly every language. The library itself is a great example of well-designed software. Start with Python. A lot of experienced devs hate Python. I sometimes hate Python too. You should start with Python anyways because it will let you get started faster than almost anything else. Most AI projects you encounter will have at least the top layer written in it. But don't spend too long in, let's do Python here. But don't spend too long in Python. Design of a language pushes you towards a specific way of thinking about problems. Avoid heavy external packages, inheritance, decorators, and generally anything else that takes you away from learning to express logic in terms of assignment, conditions, and iteration. Do iteration and functions. Write a couple basic games, applications, or tools and move on. Use UV for package management. Learn C early. C is a wonderfully simple language for writing high-performance software. The only reason I don't suggest learning C first is that it requires you to learn a bit more about how computers and operating systems work, too much all at once when you're new. A short list of concepts that you should understand. Types, typecast, structs, single pass compilation, linking, memory allocation, stack versus heap pointers. Avoid C++ for now. It's C with a ton of extra stuff bolted on that you mostly don't need. I think that's reasonable. Avoid abstraction. Always aim to solve the problem at hand in the simplest way possible. Do not introduce complexity for the sake of generality unless you know for sure that the eventuality you're planning for will actually arise. Even then, it is often better to beat that horse when it arrives. C is great for this because it takes away most of those tempting, self-defeating tools like inheritance and heavy third-party libraries. Use a debugger. A debugger allows you to run your code line by line and expect the values of local variables. Dramatically faster and more flexible than littering your code with print statements and allows you to jump around quickly. GDB for Python or GDB for C will suffice. Use an address sanitizer for C. This will give you readable error messages and is so important that I would not suggest C without one. That is true. Learn basic Unix tooling. Get comfortable with the command line ASAP. You don't need to be fancy here. Basic commands like ls, pwd, cat, head, move, copy, cd, make dir, top, etc. You'll only need the 10 most common commands 90% of the time. Ideally, use native Linux if you can. macOS is okay. Windows is not. Use WSL if you do not want to dual boot. I'd suggest a basic Ubuntu install. Do not go ham customizing everything. Get comfortable with your distro's package manager, which is probably going to be apt, not snap. Don't get nerd sniped. Programmers love inventing clever ways to do things worse and waste your time. Especially when you're new. Avoid. This is the one that's going to get me so much hate online, and it's great. Object-oriented and functional programming, they're both dogmas. Test-driven development, writing a few tests is fine. Language and distro hopping. Industry best practices, there are plenty of terrible FANG engineers. Python's type hint system. Make and C. Fancy config parsers like Hydra. Git submodules and fancy CI. Modern web development frameworks like React. Learning basic HTML and CSS is a good idea. Pricing, the latest new programming trend on X, and everything else I rant about on my dev live streams. Use Git. This one is so basic that I almost forgot to include it. Make new projects on GitHub by default and commit frequently. This is the best way to avoid losing work. It also gives you a version history for when you inevitably break something that used to work. All open source projects are run through GitHub. Don't grind LeetCode to learn. It can be a necessary evil for job interviews, but solving tricky problems with clever algorithms really isn't a good representation of programming as a whole. You should absolutely learn basic data structures and algorithms, but mastering 10 flavors of dynamic programming isn't going to be as useful outside of interviews as building more projects. I haven't taken a programming interview in years, but I'm certain 18-year-old me would do better than 28-year-old me despite not being able to build much. Something like that. It should be earlier on. Yeah, I put the language levels, I put the two languages together. I kind of did like this is less chronological, this is more like in order of importance, I guess. Not that many people. I don't think there are that many people that screw up and like don't use Git. I have seen it happen, but it's nowhere near as common. I think in order of importance, these are about correct. Don't worry too much about IDEs. It really doesn't matter that much. I use NeoVim with a grand total of 2 plugins. It's lightweight and stays out of my way. Yes, I've used plenty of IDEs. No, it doesn't matter. VS Code is fine. Just run stuff through the terminal instead of project configurations and buttons. This will break the illusion that the IDE is a magical required tool. Do not use an AI-first editor. Once you've learned the basics on your own, a code completion tool like Copilot or SuperMaven is fine. Use it to save typing and documentation lookups, not thinking. Okay, in that case, I will put this. I'll put that up there then. How to learn ML. Becoming an effective researcher is actually easier than becoming a good programmer. Most researchers are very bad programmers. Good programmers have a much easier time becoming good researchers than bad programmers. I became a good researcher before I became a good programmer. I wish I'd put more time into becoming a good programmer first. Unlike in general programming, the resources available for ML are actually pretty good. Stanford CS231N lectures are available for free online. Watch the ones by Andre or Justin. I never know if his name is Andre or Andrej, despite me having interned in Feifei's lab while he was still a PhD student. I think it's Andrej, right? Also, actually do the problem sets. This is mandatory. Look, I do not like most courses. This one is good. It is designed to teach you things without being particularly challenging. You need to know what a partial derivative is, what a matrix is, and that is about it. Don't worry if you haven't seen a derivative applied to a matrix expression before. It is the same as applying it to a single variable, except that sometimes you transpose the matrix. It's really not any harder than that. Who's Justin? Justin Johnson. In the same cohort, if you will, as Andrej. If you're in Vision, and you know the Clever data set, he built that. He did that. He did Visual Genome. He did a bunch of other stuff. I interned with Justin when I was in high school, and then I did a little bit of research with him after that. I wasn't very good back then, mind you, but I did what I could. Once you've completed CS231N, you'll understand how AutoGrad works because you built one, and be comfortable with PyTorch because you'll have used it to build other things. Congratulations, you're out of useful course material. The next step is to start reading academic papers on arXiv. Interested in a specific area of AI? Search around for a list of the most important papers and read them. This will be overwhelming at first, but it will get easier over time. I've provided you a list for reinforcement learning in the main article above. My best general advice all revolves around the understanding the limitations of the scientific process. I've been very intentional with my wording. Reread these 3 paragraphs periodically until you see for yourself where they came from. Wasn't my first search result? Well, if you just look up CS231N, I can put his full name. You can't understand how science is done. You can't understand papers without understanding the circumstances under which they are written. Most conferences enforce an 8 to 9 page limit. Since most archive papers are also either published or were intended for publication, you'll notice that they are also 8 to 9 pages. Why not shorter, even for simple ideas? Because that is both an upper and lower limit. Writing a 6-page paper will normally get you rejected. Why do so many papers have excessively formalized math, even when it's not relevant or helpful? Because reviewers like to see formulas. Also, some researchers just like writing them. Why is the paper missing X obvious ablation or control experiment? Because the overworked grad student who wrote it ran out of time in GPUs, mostly GPUs. Why aren't there more papers in X area? Reviewers don't like those. Oh, also plenty of papers are just wrong, so when 2 papers appear to have directly contradictory results, that's because they probably are. Don't trust prestige. You should care about my opinion based on what I've provably built. I use my academic credentials because unfortunately that's what a lot of people look at. So I'm perfectly positioned to tell you not to trust papers from X conference or Y university by default. It's a weak signal at best, and I've been burned replicating bogus results from people who should absolutely know better. While less common, people do sometimes straight up lie to get their work published. More often, it's a combination of noisy experiments and wishful thinking induced by 6 months of long hours at the lab. The best indicator that a work is correct is open source code with multiple independent replications and usage and follow-up work. But this still isn't a perfect signal, and I've been burned here too. Replicating the results of papers is a great way to learn, but know that this can take months. Absolutely implement some of the more basic papers when learning a new area, though. Do this instead. Look for errors. Assume publications are wrong by default, and find the skeletons in the closet. Are the experiments poorly controlled? Are the baselines too weak? Is the reasoning provided the only plausible explanation for the results? Work to decouple the content of the paper from its usually overcomplicated presentation. To the extent that the paper is correct, how does it fit in with surrounding works? Building intuition is a combination of validating claims and pattern matching. You can think of this as estimating the probability that a specific direction or method is worth your time. The greatest opportunities arise when all the papers in a specific area are making the same error. This usually happens when the premise of a topic or the standard evaluations are fundamentally flawed. Great researchers can pierce the veil of collective myopia to strike out in new directions. Cool. I think we're good with this. I can go through just the intro section of the opinionated RL guide, and then I'm going to have to go for my meeting. Unless he's canceled. Let me make sure that I don't have a cancellation. Cool, no cancellations. An ultra-opinionated guide to reinforcement learning. Reinforcement learning, I'd suggest sending it to your favorite LLM for a proof meeting. Yeah, I do that. It's kind of annoying, like, it's tough to get them to just get typos and not do anything else. Oh, by the way, that's actually how one of my papers got rejected. Funny enough, is a reviewer put my paper into an LLM for proofreading. It hallucinated a bunch of typos that were not in my paper, so they basically went, this is a sloppy paper, and gave me a bad review that biased the other reviewers. So, yeah, LLMs are really fucking dumb. Some users are like that too. Yeah, well, people are dumb as well. We're all dumb. Let's strive to be less so. Reinforcement learning is hard, and most of the material out there for beginners makes it even harder. The advice here is a formalized version of how I train new Pufferlib contributors. Some of these came in with zero programming knowledge and now help advance our research and tools. The key is to start doing reinforcement learning immediately while filling in knowledge gaps slowly and in order of relevance. First, the content here is a radical departure from all other RL books, tutorials, and references. This field is broken. Let me say that again. This field is broken. Mainstream deep learning has high-quality resources, generally sane approaches to most common problems, and a pipeline to start quickly doing useful work. The standard advice for newcomers in RL may as well just be designed to the standard advice for newcomers in RL may as well just be designed to screw with you. You will understand why by the end of this. Second, this guide assumes that you are a competent programmer, have seen at least C or C++ in a systems course somewhere, and have basic deep learning knowledge at the level of Stanford's CS231N. My definition of competent includes many undergrads and excludes many well-paid ML engineers. As a quick litmus test, can you implement the forward pass of an LSTM without importing anything? If not, or if the implementation you just thought of would be greater than 100 lines, start with the prequel article, My Advice for Programming in ML. And finally, since I'm writing this for a broader audience, hi, I'm Joseph. After finishing my PhD at MIT, I've started a quest to make RL fast and sane. Most of my content focuses on the cutting edge of RL, but this has become surprisingly accessible lately. If you haven't heard of it already, Pufferlib is my main project. It is a reinforcement learning library that is both simpler and 1,000 times faster than other libraries like SP3, RLlib, etc. We're always looking for new contributors, so follow me here and join discord.gg/puffer to get involved. The best way to support my work for free in less than 5 seconds is to star Pufferlib on GitHub and retweet this article. Perfect. So, I gotta run for meetings. The one I disagree with is React, but it's your advice to give. Okay, to be fair, I don't do a ton of web, but everything I've seen about the web makes me like want to yeet my computer and never touch like programming again. Like the modern web stack is disgustingly horrible, and like basically every single good practice and every bit of advice in front end is just like how to overcomplicate everything and make your life hell. So, I don't know. Like, there are absolutely React devs that don't know how to program. Like, they just know React, for instance. Okay. Thank you to everyone here for tuning in. This was just quick stream. I have a couple meetings. I will be back for 1 or 2 more sessions afterwards. We're going to finish this. I'm going to probably edit up my paper, so if you want a sneak peek at the Pufferlib publication, I'll be doing that since, yeah, I'm allowed to do that. There's no longer a single blind requirement because it's accepted. If you're interested in my content, you want to help me out for free, like it said in the article, puffer.ai, start the repo, join Discord,